You may recall a few weeks ago on Al's Geek Lab, I showed you this card here, the Intel Inboard 386, a card that took a very slow, sloppy old 4.77 MHz PC or an XT all the way up to being a 386. That's some serious power if you're talking 1980s. So that was cool, but what I also said was missing was some memory. The card itself had 1 megabyte of memory on board, which allowed you to run more than just the usual 640k applications, but really that little bit of extra memory didn't go very far. Now, back when the Inboard was released, it came out with an extra add-on daughter board that sat on top of the Inboard 386. If you noticed earlier with a careful eye, you might have noticed that this had an extra board on top of it. Well, those Intel Inboard memory module cards, or piggyback boards or whatever they were called, weren't very popular even back then, but obviously very hard to get on the internet today. Well, fortune has it that Harrison Frazier and Stinks and a few other people on the internet got together on VCFed, on the forums there, and made this card here, the ParrotyError. See what they did there? Parity, as in a parrot. They came up with this board here. So this video is going to be about me trying to get this to work. Now, who knows if it will work? I don't know the answer to that as I'm recording this right now. So that's part of the fun of Al's Geek Lab, right? We try shit out, and if it breaks, okay, then we try again and we try and make it work. And if it works first time, when it's almost a boring video, isn't it? But anyway, I'm going to show you this. So I've attached this to the board. You can see that it's connected via two little sort of pinouts, 40 pin connectors on there. When I got this from Harrison, unfortunately the postman had not been very kind on its way from America to New Zealand. Unfortunately, it must have been bashed around something chronic, which meant that one of the pins was completely loose or pretty much snapped off, and the other ones were all bent. So it took a little bit of time to get this back to rights again. But fortunately for me, I have a good friend who's very good with a soldering iron and had the exact type of golden pin connectors that I could put this back together with. So that's that part done, I hope. The next part is hopefully simple. I say hopefully because nothing ever is with retro computing if you've been doing it for long enough. The next part is simple, basically sticking some RAM in this and then getting it to use the RAM. Now, I already know that this card, whilst it says it does XMS or expanded memory specification, it doesn't do it in the way that you would like it to do it, which is load HIMEM.SYS and the world moves on and everybody's happy. HIMEM.SYS uses the DOS XMS driver, or is the DOS XMS driver. Everything's just fine with that. Unfortunately, that's not quite how this works. It has its own Intel above board driver for the memory. Now, we're going to see if we can make all of that happen, and we're going to see if we can make not EMS but XMS memory available to things like DesqView. If I can't, then I'm just going to have to substitute it for EMS memory.
This video is sponsored by the very wonderful people at PCBWay. PCBWay are the leading electronics and prototyping manufacturer. If you've got an idea, you can use PCBWay to turn it into a reality. PCBWay can build PCBs from just $5 and build them for you in around 24 hours. Now, what I really love is that for people that suck at using a soldering iron, like myself, you can upload your PCB file and have PCBWay assemble it all for you. PCBWay also do 3D printing, CNC machining, sheet metal fabrication, injection molding, and so much more. So if you've got an idea for an electronics project, why don't you give PCBWay a try at PCBWay.com? After all, that is the PCB way. We thank PCBWay for sponsoring Al's Geek Lab. Now, let's get back to the video.
So we're all plugged in. The only real configuration option on this card is a jumper, which is right here. And this jumper allows me to select from 2 megabytes memory or 4 megabytes memory. Now off camera, I very quickly plugged in what I believe to be 2 megabytes of memory, and it came up and said it was 1.2 megabytes, which really got me confused because I had no idea how it got to that. So I'm going to plug in some memory now and see what happens. Wish me luck. So I'm going to try some separate SIMMs, and those SIMMs are going to come off this card, which is the AST Rampage Plus 286. So that's coming out of my XT 5162. So the way that the photos look like they're set up on VC Fed is that for 2 megabytes you need 8 times 256K SIMMs, and for 4 megabytes you need 8 times 1 megabit SIMMs. So only half of each of those SIMMs is used, if I'm correct in saying what I think. So that's maybe why we're seeing weird memory configuration errors, or I've already seen them. Anyway, let's find that out by taking off these SIMMs on this. I think these are 8 times 1 megabit. So let's count them up. 1, 2, 3, 4, 5, 6, 7, 8. And then one more I think is parity. So 9 chips in total. I think that might be right. Sorry about the pretty bad shadow. Unfortunately, it is now winter in New Zealand, and yeah, the sun doesn't like to come out at all. So what I have here is my card. Unfortunately, these cards of this era, they love to use plastic to put the SIMMs in place, and these are not nearly as good as the metal brackets. They were much more sturdy. So these plastic, they really have a habit of breaking. So you have to be very careful not to snap them, which with my attention span is probably not good. So I'll try my best, and I'll do this off camera so that I don't F and Jeff my way through this. See you on the other side. So I've taken 4 of the sticks off of my ASD card. So I'm going to stick that over there to the side for right now. Stick. See what I did there? So there are 4 sticks. So these are 1 megabyte sticks, right? So 1 megabyte, 2 megabyte, 3 megabyte, 4 megabyte, right? And if we look at the ParrotyError card, this should be 1 megabyte, 2 megabyte, 3 megabyte, 4, 5, 6, 7, 8. There are 8 slots here. So by rights, that should mean that you could get up to 8 megabytes. And I think the inboard itself actually took up to 8 megabytes of expansion. But this card, because it's kind of been reverse engineered, I don't know the actual details about it, but the card only allows either 2 or 4 megabytes. So they haven't been able to figure out exactly how to get it up to 8 megabytes yet. So we have to put these in. So even though we are using 8 megabytes worth of SIMMs, we're actually only getting 4 megabytes. So I'm going to leave 4 megabytes of usable memory inside the card on my right, on the RAM page, and I'll use some other RAM I've got kicking around. So I'm going to kind of mix 2 brands, which is, you know, a lot of people probably say that's a bad thing to do, but I think it's probably okay, as long as they're roughly the same speed. These are 80 nanosecond SIMMs, and these ones are, I think, 70. So slightly different speed, but hey, I think they probably just go down to the lower speed. So if you see, like, on a SIMM itself or any memory chip, and you see a dash or a number like 80 or 100 or something like that, at the end of the chip, that usually dictates the speed. So right, so basically set this, I'm going to set this for 4 megabytes with the jumper here. Always want to max out, right? So I think we put them in from the back because of how closely they are all bundled together, right? And I think if we look up here, don't know if you can make that out, probably not, it's pretty difficult to make out on camera. It says 1, 2, 3, 4, 8, 7, 6, 5. Yeah, that's interesting too. But I'm assuming if we do 1, 2, 3, 4, then that would give us the 2 megabytes. But I think we need to put the memory in from reverse to get them to actually fit in. maybe like this, and then flick them forward at the end. And one more. Makes 8, but not, it makes 4. Alright, cool. Right, now click time. Click, click. That was as satisfying as it sounds. That's a heavily loaded memory card. It actually sits pretty solidly on, even though it's just being held on by those edge connectors. Right, let's plug her in and see how she goes. This is one beastly card. Not gonna lie. Wow, it fits, but only just. The clearance from the edge of the case and the side of the drive, I'm just thankful I put it in that slot in the first place, but that's pretty heavy going. Connected. It's posting. Here we go, this is going to check the memory now. 4 megabytes. It's checked all the memory and there's not been any memory failures. HIMEM's sitting there testing the memory and it's passed. Okay, good times. Now, that's all fair and well, but let's have a look at MEM. And I expect it to say no memory free in extended memory. Which is exactly what it says. So it's almost like it doesn't see that memory whatsoever, right? There's 4 megabytes in there, but the system doesn't see it, or at least HIMEM doesn't see it. So if you're watching this video right now and you are clued up on the Intel Inboard and somehow you know how to tell DOS HIMEM to recognize that memory, I want to hear from you. But I guess what we can do is we can have a little play around and see if there's anything we can do with it right now. So for example, if we go into DesqView, I'm expecting DesqView to also say nothing. So we go to open window and we go to memory status. Yeah, I think it means it's swapped. So if I do /s, it's slow as all hell, right? That's one thing. And if I now open another window and I go there, it says swapping. And you can see it takes a long time, and the hard drive light, I know you can't see it, but the hard drive light is, in fact you can just about making it out on the screen reflected there, but then it swaps out. And then you can see that this application here is running away now, but the other one is not running. If I go back and swap out, that other one will start running. But it's one application at a time. That's the big difference there that I want to get away from. I want to have 2 applications running at the same time. So let's have a look at that. All right, so what you can see here is I am going to update the config.SYS and show you using the EMM memory manager. Now, you can either use the Intel 386 one, the LIM memory manager, which provides you EMS and XMS, but it doesn't seem to work properly. I'll get to that in a moment. But then there's also the chance to use Quarterdec's EMM386, which is like the QEM memory manager. Apparently it was a lot better and it really helped sort your memory out. So I'm going to try it with this version because we're going to use DesqView anyway. So DesqView to the rescue. Let's run DesqView. Up it comes. Now if I run, say, the same thing, so just a DOS prompt. If I run dir/s, off it goes, right? And now if I open another window, another DOS window, same thing, just below, you can see already that one continues to run on the top. And if I run another dir/s, we can see that, okay, it's slowed down on the top, but it's still running, and so is that one there. They're both running. In fact, I should be able to run yet another. And all of this is accessing the disk in real time. It's sort of doing a roundhouse of performance, and you can see that it's probably preferring, it's saying, hey, perform better on the one in the foreground, and these two are in the background. So you can see the ones in the background are kind of running slower than the one on top. But they're all performing a task each, so it's true multitasking, which is exactly what the 386 processor was made for. and really is only something that you can properly do when you've got a chunk of RAM in there. And a chunk of RAM in 1990 or thereabouts is 4 megabytes of RAM. In fact, you could probably have 8 megabytes or so, but I think, you know, 4 megabytes in a system of this vintage is pretty damn good. So now what I'm going to try is running TCP applications. And the big problem I am curious about is whether having that low amount of conventional RAM is going to be enough to be able to run applications practically. So what I mean by that is multiple TCP applications at the same time. So we're going to run, if you watched my last video on packet multiplexing, this is the idea about having multiple packet drivers running at the same time to intercept the main packet driver. So it's like stub packet drivers, so I'll have multiple packet drivers at the same time. Okay, here are some lovely people chatting away on MRC. I'm on my bulletin board and I'm running it in a virtual console on DesqView. Right, so at the moment there, this is DesqView. I've got the EMS driver working away here, and this is the memory which is known to DesqView. So right now we can see that we've got pretty limited amount of conventional memory and a reasonably large amount of available expanded memory. So we've got about 3.7 megabytes of expanded memory available to us, this number here. And so in terms of common numbers, which is the memory that DesqView has mapped out, it reckons it's got about 12.5 megabytes, and that's through swapping and so forth. So that's cool. Let's just close that window down. Yep, and let's open up a new window. So I've created a new DOS service, I guess you could call it. Allows me to virtualize windows at the same time, so I can kind of zoom them. So if we open a new DOS window like this, it allows us to zoom that one up, and it allows us to zoom it down as well. Cool. Now, if we go to, say we want to do a dir/s, we can see that running and we can zoom that full screen and we can zoom it out again. But let's just kill that and let's go into use TCP. So to do that, what we want to do is to tell our MTCP, first of all, to run on a different packet interrupt. So we're going to do set MTCP CFG equals c:\net/MTCP MTCP.65. So we're going to run this on packet interrupt 65. I'm going to come out here and I'm going to PKT mux. And there I'm going to run the packet driver stub. And I'm going to run it on packet drive number 65. That's running. Now I should be able to get an IP address, which I am. All right. That's superb, right? So now I'm running 2 TCP applications. I'm running this one and I'm running this one here. So you can see I'm doing stuff here. That's great. Last callers, whatever. And if I switch my window, I'm running over here. So now in this window, let's go and do something else. Let's go to my Linux box. Looks good. And there's my Linux box. So I'm running 2 applications there side by side, pretty much no problem at all, which is cool. Yeah, so I can go back to my Linux box. Here I am, done and dusted. Having the ability to run multiple applications side by side, both TCP, and I can run you know, other applications at the same time as well. And they're a lot snappier now that I'm using EMS, which is, I guess, the benefit of having that extra memory. Now, it is possible as well to run Windows 3.1, I believe, so I could give that a try. Why not? Let's go crazy. The big thing about Windows is that there was kind of 2 modes. There was real mode. In fact, there was 3 modes, wasn't there? There was real mode, there was standard mode, and then there was protected or 386 enhanced mode. And the real benefit of Windows wasn't seen unless you had, you know, that power of the 386. Now, the XMS driver, it's not a good start. The XMS driver you have on your system is not compatible with Windows. You must remove it. Can I get around this by just going taking that ILM right out of the config.sys entirely. Maybe go like this, and then this, and then letting HIMEM.SYS just load on in itself. Now the problem with doing that, as we saw earlier, is that XMS itself, that's not showing anything in DOS. Windows itself handles memory a little bit differently, and if it understands what the Intel Inboard looks like, then I guess it doesn't really care. It doesn't help with DesqView. Obviously, I think DesqView can't see the inboard memory. It can only see the EMS because it's kind of presented in the same way to DOS. But now you can see that HIMEM is not complaining, and it's thinking about how much memory is in there. Now it's done. But if we go to mem in DOS, it's saying 0K. All right. But now, if I try and install Windows 3.1, I'm curious as to whether it will work now. Okay, setup is found if programs listed below on your system. When setup or Windows runs with some versions of these programs, your system may fail. The ILM386 expanded memory emulator provided with Intel Inboard 386, which is what we have, is incompatible with 3.1. It is recommended that you remove all references to this emulator from your config.sys and autoexec.bat. So we've already taken ILM out just by commenting it there. So I think it's just noticing that the word ILM is in there, and actually because we've already commented it out, we should probably be okay. So I'm just going to run setup anyway because I think it's just being a bit silly. It doesn't know that it's commented out. So I'm just going to continue. Welcome to setup. Let's do it. So I'm going to zip ahead now. I don't want to bore you with the installation of Windows 3.1 because I'm sure you've seen a Windows install in your life before. But I'll come back to you when this is all done. If you've never seen what Windows 3.1 looks like when it's being set up for the first time, here's a little bit of setup wizardry for you. If you have seen it, then this is a little trip down nostalgia lane for you. This is that exciting time when it tells you that it's set up Windows. I remember seeing this for the first time when I was young, and I was just like, oh my god, my life's about to change. It did change, but probably not necessarily for all the right reasons. Windows never really fulfilled, in my mind, the goal that it had for many people. I think probably Windows did fulfill the requirements for a lot of people, but for me, I was like, this is sucky. It's slow and it's crashy, and it's still very much like that to this very day. I'm looking at you, Windows 11. Anyway, what I noticed that is Smart Drive always likes to be loaded. Now, Smart Drive is disk caching. When you install Windows, you get Smart Drive. Smart Drive is good because it speeds up the performance of the drive, but really bad when it comes to memory. So there is that, of course. Here we go, Windows. This is running the EGA driver, which is why the color there is just white, not blue. Thanks, Windows. That wasn't great. Let's try that again. Never even gave us an error. It just literally bombed. See what I was saying about crashing? Let's try troubleshooting. Nope. What about Windows in standard mode? Surely it will go back to good old 286 based mode. Well, yes. Now that is interesting. So basically we are getting absolutely none of the benefits of the 386 CPU right about now. So that's not great. So if I go into, I think, here. Yeah, we're in standard mode. So basically that means that multitasking isn't really properly working, yeah, which is no use to man or dog. Like, what I want Windows for if I can't properly multitask. It will multitask Windows applications, but DOS applications not properly. Why is that? Could be an incompatibility with the above board. It could be that there's just not enough free RAM because it loaded up smart drive and EGA.SYS, all that stuff. I'm not 100% sure. Let's try and save some RAM, see what happens. All right, now I've taken all of the Windows guff out. Let's try and start that again in 386 enhanced mode. Bomb. I don't know, but obviously it's not a big fan of the Intel above board, so that was an epic fail. Now, there is also one other version of Windows 3.0 which was made specifically for the Intel above board. It was kind of adapted by Intel themselves. They said, let's make this Intel version of Windows 3.0 to satisfy our customers, because damn, those customers needed satisfying after all the money they just spent. All right, so here we are in the Windows 3.0 Intel above board, inboard even, setup. So this one's different. Notice it didn't mention anything there about the problem child, which was inboard. If you're interested to know what Windows 3.0 installation looks like, it looks very like installation for Windows 3.1. Okay, now we have installed Windows 3.0 and we're still no further with XMS, but let's just see if Windows 3.0 fails, crashes and burns. Here we go. I actually like the 3.0 splash screen better than the 3.1 one. Is that wrong? Well, it didn't crash, and here we are in Windows. At least it was a fully set up one for Intel, right? So, you know, we're probably, that's probably fair enough. You know, Intel had a hand in making this one, make sure it worked. And as you can see, everybody, 386 enhanced mode. The software you can actually run with Windows 3.0 versus 3.1. There's not that much software out there for Windows 3.0 that was really that helpful. But anyway, there you go. There's Windows, baby, from Microsoft. I guess the main thing is that, you know, you can run DOS with it, which is cool, right? Here's that DOS prompt. And if we do, was it Alt and Enter, I think? Alt and Enter, there we have a resizable command prompt. And if we do this here, we have a resizable command prompt. Let's just see how these things multitask. So again, my basic test is to run a directory/s, which will go through all the files on the hard drive. Look at how fast that is. If I move my mouse over here, it looks like it just stopped. So that's, yeah, that's immediately a fail, surely. That's not true multitasking. Yeah, so if I click on this, yep, that pauses. That's rubbish. Basically, that is rubbish. That's not true multitasking. That's task swapping. Not that helpful. If it's Windows applications, perhaps they will multitask at the same time, but DOS is where all the power applications really were in 1990. It wasn't until like 1992 with Windows 3.1 when, you know, more and more applications started coming over to Windows that were actually any good. But there you go, there's Windows from Microsoft, baby. So for me, I think I'll be sticking with DesqView. What do you think? I will say though, on this 386, it does, like, everything's running pretty snippy under good old Windows 3. It claims it has 20 megabytes of free memory, which is the swap file, I guess. And it's 86% system resources free, and I'm assuming that's kind of mainly RAM. So there you go. If you were running a PC even in 1991, before Windows 3.1 came out, I'm pretty sure you were best off with DesqView. I think Windows just didn't cut the mustard. It didn't offer you anything extra because most of the apps out there, as I say, were running MS-DOS applications. Those were the power apps. Everybody still ran the power apps that were available through MS-DOS. So there we go. That's the ParrotyError, a clone of the original Intel Inboard memory expansion board. Have you got any experience with the Intel Inboard itself or its original memory expansion board? Or do you know some hacks to get XMS working? I certainly couldn't get it working. Anyway, I hope that you liked this video. If you did, leave a thumbs up, subscribe to the channel, check that notification bell to all so you get all the video notifications, of course, and don't forget to leave a comment below. Tell me what you thought of the video. Of course, you can support the channel over at Patreon, patreon.com/AlsGeekLab, just like all these people did on the side here, that you can see the lovely names. So check it out over there, patreon.com/AlsGeekLab. Until next time, stay excellent and be excellent to each other. Bye for now.